Hello, today I'm going to be explaining my thought process for programming and designing the Logician's Fishing Minigame. Just a quick reminder, the Logician is a farming game, something like Stardew Valley or Harvest Moon, except our goal with the game is to inspire young children in interest in programming. And the way we do that is where in a normal farming game you'd have to do everything manually. In the Logician, you have a host of robots that you can give commands to and actually plot out with different tiles their functionality and give them schedules and save functions and so forth. Just as normal farming games have normal fishing games, the Logician needs a fishing game, but it also needs a fishing game that utilizes programming. But rather than just have more automation and more soft programming, we decided to go with something more abstract and take an opportunity to teach discrete mathematics. And how we did that was when you catch your fish on the line, you're going to be presented with a randomly generated fish, which is just a collection of sprites. And the game generates logical and or statements that you must correctly evaluate in relation to that fish. So one such statement may be blue and striped. And then you look at your fish, and if it was blue and striped, you'd say true, and if it wasn't, you'd say false. Now, so you can get a feeling for what I'm talking about, I'm going to take us into Unity, and we're going to look at how the game actually works. So here we are inside the game, and we don't have to go anywhere specifically right now, but we can run over to the water and start fishing. So here we have a small blue checkered fish, and our question is yellow or small. The fish is small, so we say true, and we get a correct answer. Another one, yellow or striped. This is a false question because it's neither, and we say false, and we get another correct confirmation. Here is small and red, and this is a false answer, but if we say true, we get an incorrect confirmation and one of our 3 strikes. The fish is small, so we can say true. And then in the event where both sides of an or statement are true, it doesn't matter as long as one of them is true. So we say true. And that was a medium fish, so we didn't have to answer too many questions. And normally you would get a fish into our inventory, but we haven't implemented that functionality yet. And we'll be getting there in the future and making further improvements. But I think you guys have a good idea of what's going on right now, so I'm going to take us into the code base. So here we are. The fishing minigame is composed of 4 main scripts: the fishing manager, the logic question, the fish sprites, and the fish. I think a good place to start would be the fish.cs script, so we'll start there. So the fish mostly serves as a vessel to hold on to the various sprites that we use to display the fish to the user interface, as well as to compare its correct variables and its contents to the logic questions. And you see these objects called fish sprites rather than just using a Unity sprite. Actually, originally I did end up using normal Unity sprites in this place and found out that there was issues when you were properly trying to display them to the UI, and we ended up having to make our own fish sprites data object, which we can go into very quickly. It's just a name field and then 2 actual Unity sprites, one for the fish display, which we see in the top right-hand corner, and one for its respective icon display, which is the symbolism used to display it in the logic questions. So moving down, we'll look at how we generate the fish. We have 3 methods for generating the body, color, and pattern of the fish. And we also add those specific body, color, and patterns to a list of fish sprites, which is how we iterate through and compare the player's answer to the actual fish. So very briefly, we have generate fish color and body, which we just generate a random body color or pattern stored within the fishing manager's instance, which has a list of each specific type of characteristic. So it has in its sprite list, it has red, yellow, and blue. In its in its pattern list, it has checkered, spotted, and striped, and we're just referencing a random index from those specific lists to get the sprites we need. and we initialize the fish sprites so things properly update. So we can move into the fishing manager. It gets a little more heady, but here you can see we have the patterns we were talking about for the color, pattern, and body, as well as a host of other variables. So moving down, as the rest of the project has been implemented, anything where we want to be able to make calls from other scripts, we're using a system of global instances that are also singletons, so we don't have any issues. Here in the init function, which initializes the list, we add those different characteristics, the lists of bodies, colors, and patterns, and we add those to a list of lists, which is how we properly generate the logic questions, which I'll be getting to in a bit. Here we have where we reach into our fish. The fishing manager always has one fish. It hangs out in the UI, and we generate the characteristics for that fish. We're not generating new fish each time we're recycling the old fish. And here we can have our start fishing, which we set a difficulty, which is just a randomly generated number between 1 and 4. We generate our fish, we generate our logic questions, then we initialize the game. I think now would be a good time to look at how we handle the logic questions. So logic questions is another smaller script. We have text to represent it, and then a fish sprites object for the left side characteristic and right side characteristic, as well as the and or boolean. And we have our constructor, which we get a reference to that list of fish sprites that we made and added things into the manager during the init function, and then we generate a fish characteristic for the left and right, as well as set our left and right. So our set and or is very simple. It's just we return a random float between 0 and 1, and if it's greater than 0.5, it's true, otherwise it's false. And our generate fish characteristics is we have a random integer, which is most of this is done through Unity's random function. We get a random number, which is in that reference to the list of lists count, which gets a random list. This we now have this random list, which is temp sprites list, and then we put in that random number into the list to get it, and then we generate another random number, which gets a random characteristic within that random component. And then we remove the list we just used, and then we generate another fish characteristic for the right side. And this return statement returns a fish sprite object. The significance of this remove at allows it so we don't get two of the same category on both sides of the question. We don't want it to ever be, is it red or blue? Is it striped or spotted? Because of course there's going to be a very obvious answer. This ensures that there are no strange duplicate scenarios. Now that we have an idea of how our logic question, which is constructed, which is a boolean and two fish sprites, we can move back into the fishing manager and start looking at how we evaluate those. Outside of more initializing the game, which is properly handling coroutines, enabling our UI, playing some sounds, we can move down to where we generate our logic questions, which is based on your difficulty. You have a number of questions associated with that difficulty, and then you run through a for loop to generate that many questions. And then we move down to where we evaluate the question, which is this is called from the UI, which just it returns a boolean, a yes or no answer, which we weigh against it. And then our evaluate question takes in whatever our current question is, and then looks to see if it's and or if it's or. We then iterate through the fish's M characteristic list, which if we go back to fish is this list, which we added these pieces to. So this list is the actual pieces of the fish. Then we check to see if the current question's left side characteristic is equal to any of those three. And then if that is true, we do the same thing for the right side, because that's how an and question works. If the left side is correct, then you check to see if the right side is correct. If both sides are correct, which is down here, then the question is true. And then if we move down to an else, which is an or question, we iterate through the left side of the list and compare it to the logic question. And if it's true, then it's true. Because if the left side is done, then you're done. And if you fail the left side, you check the right side. If the right side is true, you return true. And if both sides fail, then the question must be false. I think you guys have a good understanding of how things are going so far. The rest of this script mostly handles the logic and how the game loads between steps and steps, how it waits for the right times and handling things. And I don't think that's very important to what I wanted to show you, which is mostly trying to express how the logic and how my thought process was for creating the game. I hope you guys have learned something or at least enjoyed the video. If you guys have any questions about it or would like to speak to me, you can definitely reach out to me on my email, which is Lukas.Kirk.Nicola@gmail.com. You can also reach me on Twitter at Lukas.Kirk.Nicola. You can find all this information in the video's description below. Thank you guys very much for watching.